In this short lesson, we're going to look at how to classify polynomial functions. So let's define what a function is. This very impressive statement is the definition of a polynomial function. Since that's very complicated and hard to remember, just remember that in a polynomial function, all of your coefficients have to be real numbers and your exponents have to be whole numbers. So like 0, 1, 2, 3, 4, if you have any negative exponents, not okay. And any fractional or decimal exponents on your variables, that would not be okay either. Let's look at some characteristics. So n is known as the degree, so the highest exponent on the variable. After it's been simplified, we call it the degree. Like, think how hot it is. This first term, this a sub n times x to the nth, is known as the leading term. And a sub n, which is the first coefficient in front of that, is known as your leading coefficient. And it'll be easier once I show you some actual examples to identify these things. And finally, all polynomial functions are continuous. So let's look at a few examples of things that would be polynomial functions. So f of x equals 2x to the third plus 4. So all my coefficients are real and all my exponents are whole. So my degree is 3 because that's the highest exponent on the variable, and my leading coefficient is 2. G of x is actually a polynomial function too. Hopefully you recognize it as linear. The degree is 1 because the exponent on x would be 1, and the leading coefficient is negative 2/3. So it fits our definition where coefficients are real and our exponents are whole. H of x is another example of a polynomial function. This one is out of order. The degree would be 3, so it would be cubic, and my leading coefficient would actually be negative 11. So typically kids always think leading means it comes first. Well, if you would put this in order by descending degree, then the negative 11 would be first. Let's look at some examples, or perhaps I should say non-examples. Things that are not polynomial functions would be like f of x equals the root of x. Why? Because the square root is equivalent to x to the 1/2 power, and the degree there would be a fraction, not a whole number. Something else that's not a polynomial function would be like 1 over x, where x is in the denominator. Why? Because this is equivalent to x to the negative first power, and once again, negative 1 is not a whole number, that's an integer. Whole numbers are 0 or positive. So when we write polynomial functions, it's considered to be in standard form when the terms are written in descending order of their degree. So highest exponent first, and it descends. Let's just go through some names that polynomial functions take on based on their degree. So this has a degree of 0 because it has no x. It's equivalent to x to the 0, 2 times x to the 0. And this is a constant function. If you were to graph it, it would be a horizontal line fixed at 2. When the degree is 1, hopefully you remember that this is called linear. Next, here's a polynomial function in standard form. The degree is 2, and we call this quadratic. And when the highest exponent is to the third power, this is known as a cubic function. So something of fourth degree would just be like f of x equals, you just make something up, 5x to the fourth, and then the powers descend, minus 2x cubed plus x squared minus 3x plus 2 would be in standard form. And my highest degree is 4, so the degree of the function is 4, and this is known as quartic. To the fifth degree is known as quintic, although often people will just say fifth degree. It is quintic. Higher than that, we often just state the degree, like 6th degree, 7th degree. I'm sure if you did an online search somewhere, you'll find names, but common practice is just state the numeric degree.